we're back. We've got, we're going to cut this hole out before we go much further. And you notice I've got 3 lines. Well, this was what I thought it would be. This is what I thought it would be. And this is what it turned out to be. This distance here is 2 1/8 of an inch from underside the longeron. The longeron's about 1 3/4 wide. You want to make sure that this comes out well below the longeron, because you've got a horizontal member that goes from the bottom side of the longeron and ties into the side of the fuselage. And you want it to occur at this point or above it so that you have room for attachment. And then up here in the front, you can see the radius that I've drawn, the projected, and of course we'll find out what the actual here is when we make the cut. I'm going to cut vertically here, down to the bottom, come up across here, and tie into the new radius that I'm going to draw in a moment. And then we'll cut this out of here. I've got 3 minutes of tape left, so I got to do it quickly. Well, what this works out to is that this from here to here is 7.4 inches. And we just used this bucket here to do the drawing around. It worked out real nicely. And you'll see that's the inside line I'm going to use. Start your cut. I'm angling in on the cut. This way it's more difficult for me to make a mistake. Here at the bottom, I'm going to be very careful going straight across, and I'll probably do it from the inside of the fuselage. Okay, there's the cutout. I'm going to sand this flush right here, sand this flush, radius this out nicely. I'm going to apply a bid from 2 inches aft, around the radius corner, all the way to this face. On this particular bulkhead, and then I'm going to run another piece that'll go in 4 inches from this corner and 1.5 inches around that, and that'll complete this face. We're going to transfer the position of these ribs to the underside of the strake so that we can do T-tapes. This is a process that I haven't really described in detail thus far, but we'll do so right now. First thing I've done is I've projected this rib position in the back and put a mark back here on this rib and the one I can't get to over here on this side. Now I mark this rib here, make sure I can see that, yeah, on the inside of the strake, and I'm going to mark its center line right here. I can reach this portion of the rib, BL23 rib and the BAB, from the inside of this cut hole. That's one of the reasons we cut the hole on the last tape. I can draw the inside edge of this rib and this rib. I can get the back edge back here, and I can get the rest of the ribs pretty easily. So now I'm going to put the top of the strake on and show you that operation. Line up the Cleco holes. There we go. Now I transfer the mark that I put back here on the spar onto the top side of the strake, and I go to the outboard rib here, and I do the same. Center, bang, other rib here. Obviously I can get to the front real easily. I can see the front of that rib real easily. I've already gotten inside and drawn the inside of the rib, and I've done the inside of the wheel well. I haven't transferred the diagonal portion of the rib here to the underside. In a moment I'll be back with you and show you what that looks like and how to translate the rest of those lines to the interior surface of the strake. Back again. Here we go. Remember the mark we put inside the wheel well is right there. We know where that is. That's the intersection. But we also know that this rib is really, this is the inside edge, so we want to draw the center of this line, which is here. And we want to draw the center of this one here. Well, now I know where the center to center is. And you say, why are you so concerned with the center of the rib? I'm going to take 2 pieces of plastic tape to make sure that I define the center of the rib. I also know that this is the center here. Just translate from the edge of the lines that you drew the edge of, translate to the middle. My rib's about 4/10 of an inch thick here in the wheel well, so I'll come over 0.2. I'll do that with all of these ribs, and I'll be back with you in a moment and show you the result. All right, we've defined everything. We're out here. I've put tick marks on what would represent the center of each rib, marked out here. This is marked, that's marked, that's marked, that's marked. Now I'm going to take some white plastic tape, the equivalent of duct tape. This stuff is fairly flexible, so I'm going to run it right to the center of the rib mark. Stretch it, and now the part of this that's important is that we need to make certain that we define the center of this well, and the center of this is defined by butting the 2 tapes together. Now, if the tape doesn't want to make the bend, obviously you can slit it here and there, and encourage you to do so because you want the tape to sit flat. Do this over every rib. Don't lap anything, though. You don't want to do that. It'll hold your strake up above the surface more than you would want it to. But do make sure that it sits down, flush, tight, and conforms well to the surfaces. We're going to lay 2-ply bit up, centered over where this tape is. I'm going to give you a zoom up on where I am there. Back there. You might be able to see that when I get up close. There it is. I want you centered, your tapes centered, your 2-ply bid tapes on the bias, right down the middle of where you know your rib's going to be. I could make this piece of glass huge and make sure that I don't miss the top of the rib, but you run the risk of popping the rib off of the micro the larger you make it. So define this well and make your tape no wider than 2 inches, and you'll be all set. For those of you who don't know what an inlay is, it's a real simple operation. I've got tape emanating from the wheel well over here going into the area between the BL23 rib, the baggage aft bulkhead rib, and the diagonal rib. You can see where the overlaps are underneath. You may not be able to see them, but what I'm going to do is where I have tape lapping here, I cut away material so that I end up with just everything butting in one place. Now I can stack up numerous layers and then cut through them to generate this fit. I have to think about this for a moment to make sure that I don't end up making a fool of myself here. Let's see. We'll try this just diagonally. Cut all the way through. And I've got a lot of material here to cut away, so I'm going to do it 2 places. Now we trim away we pull away the first layers. Now this takes care of the first step. Get rid of the second pieces. I've got multiple layers here. I just want to pull the first one back and remove the pieces that are underneath. There's that one. Pull that one back. That's going to be the top one. Pull the one off of it that was on it. Pull all the pieces underneath off, making sure that they're cut all the way through. Now lay them down one at a time, back where they came from. That one lays down flush, flat. Bingo. Now I've got one left to remove, which is over here on this side. This comes up off the bottom. Put it back. It butts right against the edge. And I believe there's no tape left underneath that one. Now we have butt seams, and it's all 1 ply thick. Everyone, that's called an inlay. I continue with that same process throughout the rest of the tapes. We've already finished the ones up in front here. And there's the final result. This tape runs all the way to the front there. I'll gotta make sure that fits a little better than that later. All right, after you get your tape on, throw a coat of wax down the center, with endeavoring to make sure you get wax traveling into all the cracks, the nooks, the crannies and such, so that you don't bond between them. Now, everything you do here, if you span an area, you're going to be creating more distance, not less. So if you endeavor to make things fit very well, it will act to key your structure in place. So when we push this thing down on top of the micro that we're going to stack on top of all the ribs, it's going to take an exact impression and force you to put this thing back the same way you have it when you install it. So we must make certain that you're putting it where you want it, because that's where it's going to go when you go to bond it in permanently. Place this wax somewhat down the center. Don't wax the underside of your strake, just the tape area. This will help ensure a good release. If you have a cool shop, let it cure for a couple of days before you try to pop it, because it can release the tape from the micro, which is a no-no. You want good attachment. I won't bore you anymore with this. The next step, we're going to lay up 2 plies of bid down the middle of this. We're back with you for that step. All right. You're going to have a question right here where these lap. I'm going to have this 2 plies. I'm going to butt this one across to here. The next one I'll run right to the edge. So I've got at least 1 ply lapping in these corners. But you should have a 1/16 of an inch or so of actual gap between your rib and the underside of your strake, so that you have room for the movement of micro and the compaction of glass in some critical areas. This is where you're going to get a buildup of laminates. Assume nothing. Look very carefully at the whole process and make sure that you don't paint yourself into a corner. Back here at this back end, allow this to lap up onto the spar about a 1/2 inch or so. You'll pick it up structurally underneath the spar where it laps when you actually do the underside of the T-tape. Put 2 plies down. Don't allow more than 3 plies lapping here total. And if you do, go back to your strake and remove some material in this intersection to allow for this lap to occur when you push it down the top side. But that tolerance is quite important. Don't overfill it. Okay, you've got your, excuse me, we have all the tapes on. We'll show you that in a moment. And now Your rib is a little different than this rib. Your ribs are made of foam and fiberglass, and what you'll do with your rib is the effective representation of this, except that you're going to have a little groove. We'll show you what that groove looks like here in a moment. You can see the small groove here in the surface. Make sure I pick up a micro corner on the inside. This is not so much for strength as to make sure that when you pull the top off, you don't pull the tape right off the top of your foam. You get pretty good bond to PVC or to polyurethane, but got to make sure that tape stays in place. And we're going to get to the inside of this particular rib with a tape. We're going to do part of the T-tape on a number of these pieces that we have access to before we pull the lid off. Let me see if I can show you more of that recess. Oh, there it is there. It's not showing up very well on this camera. There it is. You plainly see it now. Go to the other side here and see if you can see that edge. The camera's trying to focus on something else. There it is, clearly visible. It's about 1/8 of an inch or so deep, and the skin has been sanded so you get a bond to it. And it's been sanded on the inside surface so we can get a bond to the interior. We'll show you the gear leg and its articulation before I finish this tape. Okay, we've got the schmutz on here. Make sure you put it on dry enough so it'll stand up. We knew we had, over here in this area, in the front, I had a little bit more of a gap, so I needed to make sure that my micro stood up tall enough to take care of that gap. So now we're going to take the upper section, and Barry here is going to swing around and show you what it looks like from a distance. This is still quite wet, so it will impart to the micro quite readily, giving a good attachment and bond. And of course, when I put it down, I'm going to be able to see the intersection between the BL23 rib, the BAB rib, this entire perimeter, and the outside ribs. There's not much I'm not going to be able to really see, giving me a fairly good indication of what's happening elsewhere. And at that time, I can remove the excess that's going to squeeze out and do a tape between the T-tape and the vertical portion of the rib. So I'll save myself an awful lot of messing around with removing micro in a large portion of the area. I'll be back with you in a moment. All right, here we go. What we want to avoid here is wiping. Then lift your edge up high. I'm going to come down here. Moan down. This way, this way. Right there, holes lined up. Straight down. Okay, down on the surface. We're going to put the clecos down the leading edge and weight it. W for one. Yeah, let's go with a couple more, 3 more. Okay. We're going to weight this thing now, and we're going to be able to show you how we're getting some oozement here. You see that, Barry? Yep. We're getting squeeze out there right now. I'm going to go ahead and weight this thing firmly along the backside. And I know that I get contact right here on the BAB rib. I'll weight that and make sure that I'm not in front of or behind the BAB rib, but directly over top so I don't bend the structures. I don't want to put a preload into any of this. Be back with you in a moment. Okay. And what we don't want to do, if we can help it, is not get micro on the tape. Oops. Because what I want to come back in here and do, excuse my arm for a moment, is I'm going to run a tape from here, from the spar, this weighted area right there, all the way to the leading edge, and I will have eliminated it hardens, and I have to chip that out from underneath and sand that area and then do a tape from here underneath. I can complete that right now in this area, inside the wheel well, and inside the baggage area. So I'll save myself a whole bunch of work and get a chemical bond to boot. I'm going to remove this, clean this up, and then put a 2-ply bid tape on this end. Now it's only going to be 2 plies around the perimeter of the tank. Everywhere else on the inside it'll be 1 ply. Don't go 2 plies on everything. I'll have a 4-ply lip, and it'll be even more overbuilt than it actually is. Okay. All right. Here we go. 2-inch tape, 2 plies for the perimeter. Take it all the way forward. Doesn't need to be quite so long. But nonetheless, you get the picture. It's not a fun tape to do, but it's one you must do. Take your brush out, stipple it down, wet the aluminum foil, rub the air out, cut it to length. Back with you for the next torture. There's your tape, 2-ply all the way around that perimeter, and now I'll show you the inside of the baggage area. Okay, this is the inside of the strake. Looking forward, there's the tape. The underside area. There's where the fuel gauge is going to go. Sorry about the overexposure there. We haven't done our 2-ply tape there yet between the side of the fuselage and the bottom inside surface of the strake. And there's the cutout opening and the canopy latch. We've just finished setting up his wings, drilling them, getting the incident set. You can see the level on the opposite side of the room. And we're going to go to the tip of the wings and set up for winglet installation, the next tape. And we have here in the foreground a drawing. I'll be able to read this here. Read this. It says here, place template on inboard surface of winglet. Now this is the winglet trim template. We place this on the bottom of the winglet, and I have a copy here in paper. And we'll quickly cut it out. We don't want to use the original. And we're going to place this on the bottom of the winglet at the center line of the leading edge. I can't help but wonder what I sound like to you folks, because I am suffering from extreme jet lag. We go over here to the leading edge of the winglet. Pardon me while I step between you and the winglet. Center line is the most prominent portion of the winglet, right here. Center line. And we take our template, and it should be relatively obvious how that goes. Take it down to the leading edge. Now we've got the remnant of a coal here. This gets trimmed back to about here because I'm not going to bother to do that because I'm about to cut it off. But I need it as a reference. The glass got wrapped around here when he vacuum bagged. I just need to know where that was. Down to there. Just mark this down its entire length. And after having done so, we're going to stick it on a bandsaw. And he has a bandsaw that'll do this. You can do it with a saber saw. There's our resultant mark. You see how that looks on video here. The line is visible. When we make this cut, don't cut through your coaxial cable. Be very careful there. I'm going to probably surgically remove that whole area before I put it on the bandsaw. And cut them both, one right after the other, and then set them up on their winglets. Now you notice that we have the airplane completely set up. We'll do the placement of the winglets on the airplane with the incidents on both wings set up accurately. And the reason that we're going to do this is that way we get the trailing edges of the winglets parallel, and we can cross-check the relationship of the two winglets in relationship to the center line of the airframe. We'll set up the incidence on the vertical relative to the inboard end of the forward corner of the aileron. But the final check to make sure that they are symmetrical will be done against measurements done from the center line. Back with you in a moment. I mentioned that I was going to surgically remove a portion of the leading edge prior to cutting this off. So what I'm going to do here, pardon the noise, I can see my coaxial in this direction. Right up to the line. I know I'm going to be going below this. Be very careful here. And removing this whole leading edge section around the coaxial. Carefully remove that, and after you've done so, and you've got all the glass removed from this, then we'll go ahead and bandsaw the rest of this, or saber saw it, or hand saw it. It really doesn't make any difference. Okay, we're back. We've done the surgical removal. And we've done a little bit of collateral damage. You can see the braid on that inboard edge. I did not go through the braid. All I went through was the exterior insulation and touch the braid, this is the most you can do without having to do a repair. The next thing I'm going to do is bandsaw away the rest of the material and hope I don't touch that thing again. It would be one thing if it was mine, it's another if it's someone else's. Well, okay, we'll go on to we'll do the next winglet as well. I haven't done this one yet. You can see it's buried in there. Just have to be very cautious, proceed a little more slowly than I did last time. Go on with your next step, and we'll be back with you as we bandsaw. Well, we're back again. We've done a repair here, and we've also run a continuity check between these two, between the shield and the center conductor, to make sure we haven't done any damage to the coaxial. Damage that would cause a short between the shield and the center conductor. Now, we make the cut. Hope you can see that line. You notice I was keeping it up so that this surface was relatively perpendicular to the blade. I don't have a way of monitoring the camera at the moment just to know what you're looking at, but I'll get in here and hand dress this to match this inside curve on the foam and the fiberglass in this corner. And we'll go do a check of this in just a moment when I'm back with you next. Well, believe it or not, this portion of the tape is a continuance of the winglets. What I'm showing you right now is what we did on another tape. Remember we were talking about center lines and everything? Well, there's a center line on the instrument panel. Remember we used the extrusions off the side of the fuselage. We just did that with Glenn. Right side, left side. Ignore that carbon, that's something he did. He also has the honeycomb, the only two airplanes that got honeycomb. Center line goes down, right over top of his main spar. Pardon the jiggle there. You notice the surface plate that he has, 8 foot by 6 foot. Surface plate underneath the airplane. There's Glenn Waters. Now, I don't know if you can see, but from the wingtip, there's a green line. You can see it along the back of his pants. A center line going through a hole drilled in the firewall attached to the wall. We know it's exactly centered. And goes to the other wingtip. You can see the green line there. We established first that his winglets had precisely the same sweep. Then we measured from the center line back to the wingtip, both sides, found that there was a 0.2 of an inch discrepancy. That's before we bothered to do triangulation off the instrument panel's center line to the tips. Once we established that, then we checked the perpendicularity of that green line to the white line by going from where that line attaches at the wall. We measured from the center line out about 50 inches or so, and then measured triangulation from the line diagonally to the green line, both sides. After having done so, we now had a reference point from the green line to the WPRP, winglet position reference point. That's the inboard corner of the aileron. You notice that nail sitting right there. Well, the first thing we did, we measured from the line horizontally to the back end of the spar on the wing, 55.5 inches. And then we went back on the white line toward the trailing edge, again perpendicular to the center line, and measured another point, 55.5, and drew in the missing 55.5 butt line. I think it can be seen right there, running from that point back through here. Now you see we've established Burt's original point. If you measure 54.5, you'll have a line that looks like this one. You see that second line? After establishing a line parallel to 55.5, at 54.5, you measure up from the trailing edge 5.9 inches and establish the point there that you see the circle line, and that will be your reference point. We'll give you the dimensions measured from that point to the leading edge and trailing edge of the winglet at the outboard end. And we've already drawn it in. I can't go any further out there, but we'll show it to you in a moment. And we haven't done it at the other end yet. I hope I didn't make you dizzy there. There's that green line again, all the way down, crossing at the center line. You can make those two lines at the same altitude by running the line through the face of the spar at the same altitude. Actually, the white line is substantially above the green line, and you use a plumb bob to establish that they are where their positions cross. We'll be back to you in a moment. Okay, there's the winglet. What we've done here, we've made sure we're relieved underneath there and we haven't done any damage like I almost did to the first one. It's cut, I'll give you a show here, through on a single plane all the way to the back. Now what you should have done before you made your cut, you should have taken that center line and projected it from where it would have been out here, well into this area. Otherwise it would be gone when you cut it off. Now you can take your template and place it back on here in plane and can visualize and project that line and then redraw it in. Now you're going to take this winglet and set it on top of your wing, and I'll show you that in a moment. Okay, we're back. There's that point. Now, of course, you're going to use the one in the center of the screen. We're using the one here with the tape. Now, I don't have much of a head on that nail, so if we lose this, you'll excuse me. But what we're going to do here, we're going to show you how we establish this. White balance there is pretty difficult to see, but it's 102.15. Sorry about that. Just turned it off and turned it back on again. I'll try and get the glare off the tape. Oops, too close. 102.15. Now remember, I'm holding the tape and shooting this at the same time and having a hell of a time thinking and chewing gum at the same time. There we go, 102.15. Now we go back to the back edge. Now if the winglet was sitting on top of here, what you would see is 108.35 at the trailing edge. And then with it sitting in place, you draw this line, and we're going to cut vertically. But the first thing you've established is that you've gone from this point vertical from the leading edge. And along the water line, measured 4.5. Now again, not from here, but measuring from here. You just put a straight edge up and measure over from it 4.5 inches. Project that up perpendicular to the water line, up to this edge. Project the line inboard and set the leading edge in there and then measure over 102.15. Here's your trailing edge, 108.35. And scribe this line. And you're going to cut vertically through here. Hacksaw, coping saw, keyhole saw, reciprocating saw, Makita, a Milwaukee reciprocating saw with a long blade with fine teeth, and proceed very carefully and very slowly. Now, what we did with these lines that we have here is we've made sure that the right wing and the left wing are absolutely symmetrical about the center line, and that the 2 points, the WPRP, are also perfectly symmetrical from the center line, left and right, fore and aft. This is very important. If you want the wing incidence, the winglet incidence, to be symmetrical to the center line, and for the winglets to be precisely in the same place, then you must follow these procedures. For those of you who are working with one wing, you would take the aircraft and set the center line up and drop and make a reference points on the floor, or lines like this on one side of the hangar, and parallel positions on the opposing side to prove that the right side and the left side are the same. It's not difficult to do. You just have to lay a grid out on the floor or in the air like this, and then place the aircraft over that grid. I believe that's probably why Burt did it the way he did the first time, was that he assumed that no one would have this kind of workspace. And by the way, if any of you are thinking, oh, I've got to have all these things in my workshop, this gentleman has been building race cars professionally most of his adult life and is a pro's pro at it. And he's equipped with unusual assets for doing this kind of a job, and he's having a great deal of fun doing it. I could spend all day showing you his tools, but we'll be back with you in a moment. We've reproduced our dimensions left side now, as we showed you earlier on the right side. We've removed our string. We've left our horizontal one there, though, from center line. And there's our damaged coaxial. We ran a continuity check, did no damage. This adds as a safety. This has been removed so that we can move the cable up and out of the way. We're going to be exposing a lot of this here in a few minutes. And I opened this up so it allowed the cable to come through here and didn't interfere as I was getting my line drawn. And Glenn is preparing a reciprocating saw, an air saw, and putting a long blade in it so that we can cut all the way through and keeping the cut line very much parallel to the vertical all the way around. We prefer to maintain the vertical all the way down. We'll be back with you in a moment as we actually make the cut. I want to describe something to you here before we went too much further. The line represents the inside edge of the winglet, but we're actually going to cut about 0.1 inside of that so that that skin has something to sit on top of, so that our final dimension ends up what we want. So this is where we're actually going to cut, leaving that 1.1 or 0.08 skin left. Back with you in a moment. I'm going to switch around.
Watch it come.
Glenn, hold on for 1 second. What was happening was that while he was operating this, it was setting up a harmonic frequency and looking like a big hourglass down here below, and I'm just holding my fingers on it to keep it from buzzing like that. Now you can see there's the cut and there's the desired line, so you can have something to sit on. We'll bond it in place and then sand it later right to the right dimension.
Okay.
Yep, shoot. Now he's hitting the shear web. Oh, actually he's hitting the spar cap. All right, I'm going to open you up right here.
Not much with carbon.
I'll be back with you in a moment. I'm going to get something to open up this kerf, and I'll be right back. Okay, we're back. There's the cut. You can see he's not quite perpendicular, but he erred on the side of caution so that it slopes away. And he couldn't make the corner here because the blade is too wide. There's your mark on the outside. All we have to do is sit on the mark. This is sloped way out, but we'll take a square and put it on here and grind this back until we have a 90-degree angle all the way around. Now we're going to go to the other side, and we'll be back to you as we begin to chew away the foam here. As you can see, well outside of 90 degrees, there is going to get real nice there. Well, I'll be back with you in a moment as we do the grinding here and the preparation on this for going in 2 inches and well, Burt used to say a ½ an inch, but sanding inside of something 2 inches with a ½ inch gap opening is impossible. Back with you in a moment. This is something you should do for your CAA or FAA. Take photographs, get documentation of what was done, and even dates if you can get it on the Come on, focus. Why isn't it focusing? It's having trouble with color or something. I'm not certain what. There we go. Trying to focus on the floor. There's the cut. It's 90 degrees. Can't focus. Let's see. No, it'll focus on your fingernail.
Is it because it's a curve?
Might be. Might be trying to focus on 2 planes. There's your nanoflow tube. Try that with one eye closed. And shear web, spar cap, upper thick, lower thin, and 90 degrees to the 2 surfaces. 4.5 inches in the line that your winglet's going to sit on. Next thing we're going to do is remove about 3/4 of an inch of material down, 2 inches in. And what you see Glenn doing here is he's going in 2 inches. There's a mark on his saw 2 inches from the end. He's cutting in, going to nothing out here, if you could see underneath. He's removing about 3/4 of an inch of foam on the vertical and 2 inches on the horizontal, taking out a wedge. And then we're going to sand this upper skin off on the underside. And there you see me moving that. Excuse me. A winter cold that followed me to Great Britain. The same tool he's using, either in hacksaw blade fashion, also works great when back cutting to scrape the micro off of the underside of that upper skin. So you're going to do that all the way from this forward corner all the way back to just in front of his manifold tube. And what we're back to is we do some of the stroking processes. Okay, we're back to with the winglet. We do the same thing to this, identical. 2 inches up, approximately 3/4 of an inch down, and I'm going to remove it with a hacksaw blade and then sand the underside of the skin until it's clean. Like we'll do in a moment, show you what it looks like before I sand. Okay, there's the cut. Skin's been removed all the way to the back of the bevel. 2 inches in. And you can see I haven't done any prep on the inside. It's still pretty goobed up. I'll get that foam cleared off there and the micro off the surfaces. And I'll be ready to get that thing bondoed to the wing as soon as Glenn is done with his as well. Okay, we're back with you again. I'm going to show you what it looks like to grind away with that saw blade. The blade, the teeth are cutting on the draw. Don't damage that coaxial. Make sure it's free and clear, 2 inches up. I'm starting to see glass. This will do about 90% of the job. Two inches. Sand it with a little bit of sandpaper and get a good look at it. Make sure that you've got fibers exposed and no micro left on the surfaces. You can see the mottled look with the micro left in the surfaces. And you'll be able to see grain orientation here before much longer. We'll also take sandpaper to the foam and clean up the edges so that it's less likely to generate dust as we go on with the process. Okay, we're back online. I want to show you real quick here. I've got a 80, 90 thousandths piece of aluminum and some 40 grit. And you can get up in here. The winglet went 1/4 the length of time that this takes because it's so awkward to get to. You have to remove all the micro and get down to shear web here. This is going to be glass when you get down to it. It won't be black like this will. This will turn up carbon fiber and you'll start to see it on your stick. Keep working it. You can put a mark on this sander that shows you 2 inches of travel and that you're not going any further. And that looks about right. Clean it up. Don't get lackadaisical. This sees compression loads. This whole winglet is designed to be able to fly at 175 miles per hour sideways, and you won't accomplish that if you don't do your prep correctly. So really make sure it is prepped well. No shortcuts here. Nothing black yet. I've got a lot of sanding to do. I'll be back in a little bit and I'll show you what it looks like up inside there with some light. Okay, we're recording. I got a flashlight underneath there. And that's what that looks like. It's black. You notice the shoe web has not been cut. Go all the way back here to the nyloflow. And we've got full complement of 2 inch removed all the way across, clean underneath. That's how it should look, folks. Now you notice the back's a little thick. It can go to nothing if you're really dexterous. And This is Glenn's first one. His second one is absolutely perfection. He did it in half the time he did this one. And we've shown you the winglet. Now we're going to fit the winglet, and we'll match the other winglet, the right winglet, to this one. Okay, now that we've done all the prep, we've gone back to our marks. And you can see them there. There's a little parallax here, so if I were standing right over top of it, it would be right over the mark. You see how this dimension is plus or minus 0.05. Glenn happened to have all this great stuff floating around his shop that we could lean this thing against. You're going to have to make this up as it goes. Now, if I look in the back here, there's the made up at the rear. It's just sitting on a barely on an edge. There's the edge of the glass. There's the coaxial. And now we're going to put prodigious amounts of Bondo in that corner from back to front, and take a piece of wood and run it from somewhere up here to somewhere down here and Bondo it in place. There's the aforementioned wood. We can even get fancy. Something like that. From there up to there. Just needs to be diagonally stable. And we'll be back with you as we apply the Bondo. Okay, here we are. We've just added the Bondo. Oh boy, it just went off. Bango. Still rock solid. We just checked this again. 102.15. We checked 108.35 on the trailing edge. We checked the string to the trailing edge off a vertical, 4 inches off a vertical. And I also checked to make sure that we still have the line in here. Of course, the line doesn't mean anything unless, if I have 108.35 at the trailing edge. All things are in the correct place. If I don't back into something here and destroy something, I'll be just fine. That's how it's supposed to look. Off the vertical and attached. And here's the lucky man who's going to take a photograph.